Hi everyone, welcome to our webinar. We're very happy to see you here. We thought that it's now we're approaching by the end of the year, so most of you are probably building your product security program for 2024. So you might need a little help with building all different steps there and to try to understand all the attack surface of your organization. You need some help to identify some of the security gaps. So today we're joined by Tristan and James. So Tristan is the co-founder and CEO of Escape, the API security platform. And James is an expert in DevSecOps. He's been already in technology for over 10 years across engineering and security. So firstly, we're going to present you the essentials. So really help you to understand all the foundational elements of product security, why all these elements matter. After that, we're going to show you how you can identify potential vulnerabilities and threats and tailor those specifically to your organization. Then we're going to cover all the best practices you need to secure your applications effectively. After that, we're going to help to show how you can align your security roadmap with the industry standards, covering SOC 2, HIPAA, PCI. And at the end, we're going to cover the incident response, so have to help you prepare for the unexpected threats or actions with a very well-defined plan for handling different security incidents. So now I'm going to give the hand to Tristan.
Thank you, Alexandra. Hello, everyone. Thank you for being here, and I want to thank personally James for joining us today and sharing his knowledge and expertise on the topic of building an application security roadmap. So James has a lot of experience in the field, and I'm really glad that he could join us today to share this experience with us. So as Alexandra said, I'm Tristan. I'm the co-founder and CEO of Escape. We are specialized in API security, but today I'm speaking about the broader topic of application security. And I will start by explaining the essentials when crafting your product security roadmap for the next year. First, before starting to create the roadmap itself, the first important topic is to decide what are the goals. Why are we working on creating a product security roadmap? What is the objective that we want to achieve? And especially different topics that are important when defining the goals that you want to achieve with a product security roadmap are what is the kind of risk that we need to mitigate with a product security for the company? How important is the product inside of the company, and what are the risks that are threatening the product? And especially also, are we doing this for compliance because we need to comply with specific standards for security, or because we fear that our data would be stolen, or because we fear that our product would get downtime or be a victim of denial of service? So understanding why we are doing this application security project, why we're trying to protect the product against hackers and against external threats is important. The second thing that is important is learning and understanding. Your product, your company, and your users. And especially, you must become an expert in understanding how your product, your company, your internal developers, people inside of your company, and your users interact all together to use your product. If you're not able to answer the questions, what data is your product handling? How important is the reputation to your company? What happens to your users if your product is down for an hour or a day? It means that you're not perfectly understanding yet what exactly how your product is integrated into your broader business scope and how to protect it right. So understanding and being an expert of the product that you actually need to secure is very important to create the right strategy and to prioritize the right steps of any product security program. third part that is important, and it looks like it was changed in the presentation, but anyway, if you push a line of code into production, so starts from understanding if a developer writes a new line of code in my product, what is the process to put it from the IDE of my developer into production? Does it go through CI/CD? Where is it deployed? What are the different tooling that will manage and transform this line of code? What are the external libraries that we're using? What are the tools? What are the processes? Who is reviewing the code? And so on and so forth. You must understand precisely every step of the process, from the developer's ID in the developer's laptop to the code running into production, and what are all the steps and all the tools used in between. The first step is creating a map of the different teams and the code that they own. The idea behind this is you need to identify who is responsible, who would be the person that will fix the bugs or the critical vulnerabilities that would be found in the code. So you need to have like a precise idea of what is the ownership in the applications that your company is building, that your organization is building, and who you need to reach out to when there is a vulnerability or when you need to discuss important security topics. And the fifth step is to have diagram of applications. Understand what are the data flows in your product, how the data is stored, how the internal networks are segregated, what are the APIs technologies that are used to exchange data, where are the authorization and authentication system placed in the product, and how do they work. If you have a precise understanding of the data flows in your product and the data storage in your product and all those microservices are working together, it will help you a lot identifying the weak spots and the potential attacks and threats on your product. And the last thing, and it is an important one, you need to understand what tools you already have for securing the product and identify the real gaps that the tools that you have are not covering yet, and then find the right tooling to help fix and monitor the areas that are not tackled by the tools that you already have. So thanks to Tech, which is a nice project that James created, we have like a huge database of tools for different steps in the project, from the developer's laptop up to the running code and to the interaction with users. So if you want to check that out, I encourage you to go to Tech and check this really, really great database of different tools that you can use for implementing all the security through the development process up to the running code. So that is the basic, and now I will let James handle it from here and work on and explain the more in detail part of creating an application security roadmap.
Yeah, thanks, Tristan. Just something to point out about this slide is it's really supposed to illustrate how overwhelming, like this essentially could be your roadmap, right? As far as we want to do every single security thing that's humanly possible. And that's why I think step one from these goals is the most important, of how much risk do we need to mitigate? And are we doing this for compliance? Back when I did a lot of like SOC 2 automation consulting, like it would be usually about halfway through the sales process where the team would sort of understand what the scope of a SOC 2 audit was and figure out, like, are we doing this because we just want to get a successful SOC 2 audit piece of paper on the other end because we need to close this deal in a hurry? In which case, this list that you're seeing gets narrowed down to like 3 things across all of it, because you're just trying to check the box to go as quickly as possible to get a SOC 2 completed. Or are you trying to build security over time because you're really nervous about the kind of data that you're storing, right? So this was like people who were like healthcare startups always had in the back of their head, like, man, we are collecting some seriously sensitive data and should be trying to mature our security program in a more realistic way. And so really the goal is going to drive how much of this you're doing. And it's going to drive everything in your roadmap, including talking about things like risk assessments. And so a lot of CISOs want to prioritize their security program based upon risk mitigation. And what can be challenging about this is that a lot of engineers uh, don't have a realistic idea of where the risk actually is because they're too in the weeds of, like, I know that this secret isn't handled properly in this particular application context and I've been wanting to redo it, or our firewalls need an overhaul, or we need to switch to this tool. Like, they're all very focused in the weeds things. And so one of the takeaways from ThreatModCon had its first threat modeling conference before the OWASPCon this year. And really one of the big takeaways from that event was that everyone can help find risk, right? We think of threat modeling as this thing that application security wizards who have been doing it for 15, 20 years, who are total experts in whatever language you're using the application in. We think that they're the only ones who can do threat modeling. But threat modeling, when we look at how breaches actually happen, usually it is a DevOps engineer whose personal computer had private keys on it, or it's a leak of an application key to a GitHub repo from somewhere, or it's someone spoofing a user and calling in a help desk ticket to reset their password. It is very simple, low-level IT processes that get you actually hacked the majority of the time over any of the cool, nerdy stuff that I love working on, that I'm sure Tristan loves working on. But that's why the goal is you have to involve other people in your risk process, people like your customer support team, your help desk team, those, I'll say, lower level teams, because they're the ones focusing on the more day-to-day operational things instead of purely application developers, right? Where you get in this weird silo of trying to have this crazy level of like injection protection, when at the end of the day, someone could just call up your help desk and ask for a user reset password because it's all public. So that's just what I mean by really make sure that when you're doing a risk assessment, that you're thinking in terms of those low-level entry points into your business, and trying to include stakeholders from outside of just the purely technical departments into the process. So then a couple of ideas of how to make a diagram is, I think, the key to a successful risk assessment. This diagram I picked sort of arbitrarily from AWS's documentation because I think it is a good example of the kind of diagram that you want. Because what we're tempted to do is to get some shiny new tool like a Prisma Cloud or something, and it's got like a nice little graph of all of our Kubernetes connections across everything. And we think, there's my application diagram. But the problem is, if you actually try to use that diagram in the context of a risk assessment, all you have is a million different namespaces and pods that are all just talking to each other. And it's totally useless to then prioritize, like, okay, which one should I actually focus on? Where's most of my risk? Like, you're just chasing this crazy rabbit trail, versus a meaningful diagram is going to be logically based from the application layer, where it's like, here's a phone number coming in, and then we're encrypting it, and then we're running a Lambda function on it and storing it in a DynamoDB table, and just walking through the life cycle of the sensitive information that you're actually trying to protect is going to be, all right, maybe we should prioritize this year assessing our encryption for our phone numbers, or maybe we should assess the vulnerabilities of our Lambda functions that are handling those phone numbers, like really narrowing the scope to where you're going to have the biggest impact to what you're actually trying to protect. And the next idea is tracing a piece of code from IDE to production. And that's something Tristan brought up as well in the last slide. And it's important because when you walk through this process, you'll see the things that your developers are actually doing, because a lot of the time it's going to be things that you're just totally unaware of. Things like developers who like, oh yeah, we always just run this script in production that we all just SSH to this box and run it. Or things like, oh yeah, the CTO has a server under his desk that is actually keeping everything working, and you have to ask him for permission to push something. So that's where it's just, you uncover these giant risk areas just when you go through the process with a security mindset of just deploying something yourself. So those are ways to start the risk assessment process. But then when it comes to actually, you want the outcome of a risk assessment to be greater funding for your team, and basically a roadmap for the year of how are we going to fix these things that we found. And so the first thing to think like is to think like an attacker in terms of what would be the easy, if I knew nothing about this web application, or if I knew nothing about this business, how would I get into their business? And so usually that's whatever the front door of your application is. And then things like we talked about, the lower level, like help desk, business processes, customer support, those types of things. But then when you're building this report, you want to think like the executive shareholders that are ultimately hopefully going to be the ones getting the outcome. And so for a CFO, you don't just want the outcome to be all of our phone numbers could get leaked. You want it to be in the event that our phone numbers get leaked, it would cost the business this amount of money. Or something that I've commonly run across is like people using application for fraud use cases, right? And so you can tell the CFO, we are losing X number of dollars per year on fraud, plus the engineering time to investigate the fraud, versus if we implement this program to fix it, then we will reduce costs by doing so. Same with implementing DevSecOps processes, right? Where if you, instead of just saying we should do DevSecOps because it's cool and it's what everyone is doing and in pipeline scanning, whatever, you can really focus on how, if we solve these vulnerabilities earlier, here's how much engineering time we're saving. And same with thinking like a CMO as well, in terms of what type of data is going to be the thing that harms our reputation the most. And then on the flip side of that, you have to be realistic, because your business might frankly not have, you might not have the need for as strong of a security posture as other businesses. And as an AppSec leader, you can be okay with that recognition, right? That you're trying to balance the speed of deployment with the amount of security. It's not your job to always be maximal security guy, because if we go back to that diagram, like maximal security guy has plenty of stuff that they could push on people to do and make it so code never makes it out the front door to production, right? The least risky thing to do is to never ship or change anything. And so it's really important to identify what is your actual risk if something were to go down. And then finally, the way to actually exercise all of this is performing tabletop exercises to really identify those gaps and to work with other teams in doing so, right? The most successful tabletops I've had have been through, okay, if someone did get into our application runtime context via supply chain attack, what could they do if they got a reverse shell to a pod from a supply chain takeover? And then working with the DevOps team to like, just usually all you have to do is run a print env on a pod and it's like way over permissioned. And then you've just started like, there's your roadmap, right? Of we need to identify supply chain stuff. We need to create an incident response plan. We need to limit pod to pod permissioning. How can we further get runtime protection? There's a million different things that a tabletop will reveal if you actually take the step to involve those teams instead of just like theorizing it or keeping it like purely executive driven in terms of like how much money would we pay or how long would restoring a backup take. So those are all general tips for using risk assessment to build and fund your roadmap and program for the year, which is what really the end goal of doing that should be. But I think I'm passing it back over to Tristan for the
yeah, before we move on to that, like to the best practices, James, like if I take a quick look at what you said, from your experience, what is something that developers have neglected when doing threat modeling? I mean, if you start doing threat modeling, what are the things that you might uncover about the developers' misconceptions or about where the risks are?
I think especially with developers sort of being forced DevOps as like a thing that they never really asked for. That's like, congratulations, you get to manage your own infrastructure now as well. Like usually devs are very much like, oh, I know a bunch of spooky stuff you could do if you manipulated the app in a business logic sort of way, or that we don't validate like cross-site requests forgery well on this endpoint or something like that. But the stuff that they usually don't know very well is like, how open is our Kubernetes cluster? Like, do we have the management plane like IP allow listed or not? Those sorts of more infrastructure, like what's our WAF look like? What are our network protections like? That stuff usually gets like totally missed in a threat model. And then obviously like physical security is nowhere on their radar. It's not on the radar of most cybersecurity people. And same with like those help desk workflows of like, how are you making sure that because in the same way that devs have been handed DevOps, help desk has sort of been handed like complicated Okta permissions management. And so do they have proper controls in place to really like maintain and monitor what's happening when someone requests access to an application and that sort of stuff?
Yeah, I perfectly understand that. That's very clear. So going back to best practices, there are a few things that are important to know about when you're kickstarting a product security project and planning a product security roadmap. And first, there is a common misconception that security is only about hard skills. Security is about hard skills, but also a lot about soft skills. And especially, this is what you said, James, like security is about like creating a relationship with the developers and the other stakeholders that are creating the product. Because if you are only putting like fences for deploying new stuff and slowing everything down, they will find other way to bypass the security controls and do their own stuff in any way. So the idea is to keep the relationship going with the developers, with the stakeholders, and balance the security and the understanding that also people have deadlines and have productivity metrics that they must respect. So getting the developers to understand that security is important and getting them ready to do the efforts needed to create something secure is a critical step in having an efficient product security strategy. A second thing that is quite important, but I think like nature is healing, and this has been a practice in the past decades, but it is slowing down. The goal of security and vulnerability management is to fix vulnerabilities and not to build dashboards to observe thousands of them. And it's especially important to understand that if you are able to detect all the vulnerabilities, but none of them are fixed by developers, then you're not really succeeding. So remediation, accompanying the teams into remediating the findings, helping them to remediate, prioritizing what needs to be fixed in order to help them fix it, is something very important. Linked to that, like if you already have 12,000 vulnerabilities, onboarding a new tool might not be the solution because it might just create new findings that will never be fixed. So onboarding a new tool is something that must be thought about before doing it, and especially does it really closes a gap that we have today in our security strategy, and are we already able to manage the existing vulnerabilities that are found by the tools that we have? And this is an important consideration to have during the project. The idea, like ideally, we would all have like a validation at every step of the development process. Like developers would have like tests for the open source libraries that they use, the open source packages. They would have like tests in IDE during the CI/CD, during the pre-production, the production environment, the QA environment, and it would also have like a proper monitoring in place and a lot of tools. But we have to prioritize the roadmap because not everything can be done in a single place. So we need to understand precisely where we want to tackle the issues first. And at the end, something very important, especially because we're talking a lot about DevSecOps and shift left, I've noticed that there are roughly two kinds of companies today when it comes to security, or at least two kinds of modern companies. There are like the traditional ones that are when a new vulnerability appears, the security engineer analyzes the vulnerability, decide if it's like a priority to fix it or not, and they create a Jira ticket for the developers to fix. And there are other companies that embraced fully the DevSecOps approach. And in this case, the security engineer do not even know about the vulnerability yet. The developers directly receive the alert. The deployment is blocked if a new vulnerability appears, and they have to fix it in order for the new version of the code they're working on to be pushed into production. So both approaches actually have pros and cons. if you have the security engineers or the security team to be involved at every time a new vulnerability is found, it can slow down the process and the remediation process, but it can also help avoid overwhelming the developers with many vulnerabilities or many alerts. On the other hand, if your developer directly manage the alerts, they can fix it more easily, but probably they can become overwhelmed like faster when there are many alerts that come out of the security tools. And this is especially true in the case of SaaS tools and static analysis tools and software component analysis tools that can very quickly give a lot of alerts to developers.
Yeah, and Varun, let me respond to your point because something that comes up a lot in terms of something I emphasize all the time is that fixing vulnerabilities is the priority over dashboarding them. And as someone who also has to get executive buy-in, like I totally understand that your CISO really just wants to know like who they have to go yell at when they get the vulnerability. And the problem that this relationship fundamentally takes if you view what I'm really getting at is like, what's the fundamental outcome that we're going for? And if the outcome is I'm a security engineer and I like my job and I want to keep it by making dashboards for my leadership, and then the CISO is using a hammer all the time to say, why does the infrastructure team have 10,000 vulnerabilities and it's only gone up month over month? That relationship that you have with that team is fundamentally broken because they're just going to endlessly get this work stream from security that they're going to complain about and say like it's totally out of touch. It doesn't make any sense. We have all these vulns because we have like these servers that can't get fixed, and it doesn't matter anyways because they're not even accessible on the network. And these fixes they don't actually matter because we're going to decommission that service anyways. We've been wanting to fix this forever with like getting a network change. Like they have their own plans that all of this picture of the vulnerabilities they have goes into. And so really what I'm trying to emphasize is that the conversations with those teams should be based around here is generally the vulnerabilities that we're looking at. How are we going to go about fixing them? Instead of sort of this workflow of like surfacing the leadership reports, which then come down as hammers from above to everyone else. And let me use an example because it might be helpful in terms of like the way a lot of these tools will roll up like Linux vulnerabilities is especially painful in terms of like if I don't think in terms of how do I would create a ticket for a developer to like run apt upgrade on this group of servers and then or on this like golden AMI and then redeploy the server. Like that's a ticket that makes total sense to them. That's something they can easily do in a day or so, right? As a very low level of effort ticket. But if I instead create, 5,000 tickets of every CVE that exists on the system, and then I'm especially screaming about like, here's this CVE that's like a 10 out of 10 exploitable, like we need to fix this immediately, drop everything. And then they're SSHing onto every single Linux box because they think that like all they know is that this is an urgent to fix critical priority. And so they're spending now a week SSHing individually server by server to upgrade this one like package or mitigation for a CVE when all they really had to do was like run an apt upgrade and redeploy their golden image. And so that's all I mean is like, if US security can provide the context based on how they're going to actually fix it, instead of based on like, here's the CVE we're seeing and why we're freaking out about it, it can just help make the whole process go more smoothly and ultimately faster as you're still, either way, you're patching that vulnerability. It's just when you think in terms of the fix, you're fixing a lot of vulns for very low effort versus if you think in terms of the CVE and the priority, you tend to create like a ton of operational headaches that might not actually fix the thing that you're trying to fix. And so it's not that I think the dashboards are useless. Like executive buy-in is key for getting all of this stuff done. It's just that ultimately just staying focused on like the outcome out the other side is working with the developer to fix an issue as opposed to the outcome being, getting that team in trouble from the executive. Yeah. So I will hop forward now to the compliance frameworks in this journey that we typically see. And so most product security roadmaps are ultimately being driven by some sort of compliance outcomes. And so really, I just wanted to go through this because a lot of times security can go down to security can come down to trying to chase these compliance goals, like their gold stars or something, to sort of catch them all because it's what you feel like you should be doing. And so this is the typical journey to see, just so that you know like where you fit in this as an industry and what you might want to pursue. But ultimately, I view the most basic point here is that I view compliance as an outcome of security, not as like the goal of security. And so what I mean by that is that if you're doing everything really well that you should be doing from a security standpoint, the compliance thing should boil down to like creating a couple of paper policies, not some giant technical hurdle that's going to take years and years to do. And we'll talk about that with FedRAMP, because FedRAMP is sort of an exception to that. But typically SOC 2 is the starting point, and this is much more of an American thing than a European thing. But the reason that SOC 2 has sort of become table stakes for dealing with large enterprise clients. And so typically a startup runs into this when they go to talk to any Fortune 1000 plus company and say, this is going to be that startup's first major deal. They're super pumped. All of a sudden their sales team gets asked for a SOC 2, and then all of a sudden everyone scrambles because they don't know what that is or how to get one or whatever. And so you have a whole industry like Drata, Vanta, Secure Frame, all these different, a lot of different providers in this automation space. But really, even what they're doing is sort of around this confusion of like, what is a SOC 2? And a SOC 2, it's important to know, is you're getting audited on your following of your own policies. And so a SOC 2 requirement is like you do vulnerability management. And you have a ton of freedom to define what vulnerability management means for you and your organization. And then the auditor comes along and says, yes, we have validated that this organization is following their own policies for that. And so SOC 2 can be very scary, but really what it is an opportunity to sit down and think about what you actually want your security posture to be across these like broad goals of what to accomplish. And so don't think of SOC 2 as like this stringent set of standards, which a lot of those companies help you by providing you with their control set. And so they're auditing you against what they're saying you should be doing. So stuff like if you start SOC 2, you could say that we force branch protection to where only developers have to create pull requests and they can't merge code directly to production. And so that's a control that you can choose to implement, and then those tools will like check that you've implemented it. But you don't have to even do it that way. So you have a lot of freedom to set your own standards for SOC 2. And then typically after that comes ISO 27001, which is a much more international standard. And really, if you've done a good job with your SOC 2, you can get through this one pretty easily. The major hangup that people don't expect is that part of an ISO 27001 audit is an on-site visit and looking at things like your server closet, your network configuration in your offices, your physical security stuff. So just keep an eye of that, like that's coming with ISO 27001. The rest of it is very similar to SOC 2, just with a little bit more rigid standards to it. So then with those two things done, there's a lot of questions around, do we do high trust or HIPAA, PCI? And the first things that I just want to say about these compliances, like, first of all, HIPAA is not something that you can be like HIPAA certified or something. Like, you can include HIPAA as an additional part of your SOC 2 audit in terms of saying, here's our HIPAA controls. The auditor has validated that we enforce those controls around HIPAA for protecting healthcare data. And so that's really it. Like, HIPAA is much more of a loose, like, marketing thing in terms of saying that, like, yes, we do it. And you do have to do it. It's just that there's no regulative, like, you've passed a HIPAA audit or whatever. High trust is the version of that does have an actual you are getting audited according to standards of how you're handling healthcare data. And PCI is tempting to do, and really all it is, PCI is complicated because it's very much focused on the network controls and the data encryption controls around cardholder data specifically. And so I wouldn't recommend it as like just a general security practice, because it is very much focused on cardholder data and how you're protecting it. And so essentially, if you try to apply this outside of cardholder data, you're essentially saying that we treat all of our data as if it was cardholder data, which is fine. It's just going to create a lot of weirdness when the audit's actually happening, because you're having to try to differentiate with the auditor, like, oh, we don't count like our server host names as PCI data, for example. Like, you have to define for them what you're counting as if it was PCI data. So it's just kind of a weird thing. And there's a lot of hacky workarounds for PCI, but those are generally those things. And then generally, this is about the point in maturity where a company will think about doing a FedRAMP assessment. And the most normal outcome of a FedRAMP assessment is, yeah, we're not going to do that. And the main reason for that is because FedRAMP is the only one of these standards where it's not enough to say, like, here's our vulnerability policy and here's evidence that we generally follow that policy. It is, we are giving the auditor the raw output of our CVE and vulnerability data from our authorized tool. And then they are tracking, have we remediated that vulnerability month after month? And have we missed any 30, 60, 90 day or 30, 90, 180 day timelines on that tool output? And so FedRAMP is like the gold standard because there's no hiding from it. But with that is, you have to do a lot of things that like don't make sense, right? Like, you have to treat a CVSS of a high, even if it doesn't apply to your environment, like, at all. There's ways to false positive that stuff, but you have to track it. And it is all extremely CVE by CVE. Here's justification for why this doesn't apply to us. Here is how we are dealing with it in the future. Here is how we are verifying that it doesn't apply to us at any point. So you just get the sense that it's much more granular, and the amount of change control you have to have is often too much for organizations. And so that's generally the journey, and you can pick where you sort of fall into that. If you have nothing, I would suggest start thinking about SOC 2, because a SOC 2 is always going to be a useful thing to have, because it shuts down a lot of questionnaires. It shuts down a lot of questions about your organization when a company can just sign an NDA, you give them your SOC 2 report, and that's generally like the cost of doing business in B2B software sales. And then from there, you can sort of scale to what makes sense. And if you're looking for supplemental standards, this is the column on the side that I think is the most interesting and helpful in terms of things you can add. And the main power I've found in doing this is that it's sort of like this secret power of unlocking funding for whatever tool that you're going after or that you want to add, in terms of, if you as an organization have committed to, we are going to follow the Cloud Security Alliance guidelines for our AWS configuration, or we are going to follow the DevSecOps maturity model, or we are going to prioritize the OWASP top 10, and then quarter after quarter show how you've grown in each of the different areas. That is sort of the key to saying the conversation no longer comes down to, do we really need a DAST when we're doing SAST and SCA? What's the actual value? How am I going to prove this value out? Instead, it's, we've committed as an organization to this maturity model, and this maturity model says that getting a DAST is a part of meeting its requirements and standards. And so, like, it's no longer a question of, is there a real value in this tool? It's a question of, are we going to follow this standard or not? That's a well-recognized standard. And that really shifts a lot of the conversations around like getting funding and buy-in for different tools and programs, when you can just say, hey, look, we've committed to following this stuff. The last note I wanted to make on this is CIS benchmarks are the big scary thing that just something that most tools will like have, like SOC 2 ISO scanning, and then they'll have like your CIS benchmark scanning. And all I want to point out is that like nobody has 100% CIS benchmark scores. There are a ton of CIS benchmarks. They're a great model to follow, but it's important to recognize that when you turn that on as a standard for yourself, you're going to just get thousands of alerts by nature of what they are. And a lot of them are not going to apply to you. And so that's just a note of like, it's really well dispersed and there is value in it, but just be aware that if you set that as your guideline, you're going to have a lot of work ahead of you to go over that. So generally, that's how these industry standards compliance frameworks work. I'll pause for a second just in case there's any questions before going on to incident response.
Actually, I have a question for you, James. So here you presented, and thank you for this, like the different industry standard framework for security. And we both know that there is a difference between compliance and actual security. So say if we wanted to have like the best security, and I'm not talking about compliance, but real security.
Yeah.
In your opinion, what is the standard that actually guides you towards the best security? Because I know, for instance, that SOC 2 is very permissive. You can create your own policies. But if we have a standard, I'm not talking about FedRAMP because this one is perhaps a bit too much. But what is the standard that actually creates real security?
Yeah, I think it's a couple things. I think like the CSA and then like I think the DevSecOps maturity model is really good. Same with SAM. Like a lot of the OWASP stuff is going to be better because there's no like corporate backend to it, where they're not trying to sell you their auditor assurance package as well, right? Like it's just here's stuff that we think is actually helpful. Same with stuff like the Kubernetes top 10. When you get into like some of the more specific top 10s than just the OWASP top 10, there's a lot the ML top 10 type stuff. There's a lot of general guidance there that's really good. I generally like the CSA standards, but with any framework, what's hard is you're just going to not be married like super closely to it. It's not all going to make sense for your org. And so that's why sort of going back to that diagram of all of the possible stuff, like basically this is my personal, if I wanted the max security, what could I do? It is basically this. And part of that is buying the right tools that also care about security and not just frameworks. Because I typically find that those are the ones that actually provide value. So just to give a couple, because I'm most familiar on like the Kubernetes side, stuff like you just notice that every tool had like Sysdig just announced their own. They added a couple of rules that were detections for like role assumption and malicious discovery of resources, and like that's their own rule set because they care about security as a company. That's not like tied to some framework. Same with like Wiz's configuration scanning versus every configuration. Like here we're scanning these benchmarks. But even open source stuff like the Prowler stuff, like tons of different. It really comes down to the scan, and I'm sure Escape has their own examples, right? Of like here's scanning we do because it ties to a compliance framework versus here scanning we do just because it's like, hey, this is actually like a bad thing. So a lot of it is like leaning on the actual tools. And then I'm looking at this question from Varun around if we consider maturity models as a framework to implement as it is, or like a North Star for your security projects programs. I kind of view frameworks as like a South Star, if that makes sense. Of like, I don't the frameworks. I always view the frameworks as lagging behind actual security by their own nature. Of like, some security thing gets discovered, and then people talk about it, and then they implement it, and then it gets included in the audit standards, and like it's sort of this. I view it as like the bare minimum bar of like, let's make sure we're doing all of this stuff well, and then we can actually excel in security after we've done that. And the reason I wouldn't use it as like a North Star is because I think so. Some like what I just said applies to like SOC 2 and ISO and maybe even CSA, but it doesn't apply to like CIS. CIS you definitely could use as like a North Star. The problem with doing that is like it's just so granular that you're setting like an impossible standard as the thing that you're striving for. and I don't necessarily think that's super helpful either. So all that to say, it really depends on the standard. But in general, I treat compliance frameworks as like the bare minimum of what we should be doing, and then anything else is like bonus security stuff. Yeah.
From our experience, the the the, the model, like the maturity models, are falling behind, like are late according to the real state of security and the latest threats that exist. But most companies are actually lagging behind the frameworks themselves. So generally, I would consider it on my end as a good food for thought when creating a security roadmap, being sure that you didn't forget anything and that you considered things in the right order. But everything has to be seen through the prism of the threat model that you started thinking about, that is related to your own company and not being implemented as is. Security like is something that is very tailor made for every organization. Every organization is different from a security point of view, and applying any kind of framework as is might not be the best way to implement the security controls.
Yeah, let me give an actual example too, that might be helpful as far as like a SOC 2 ISO requirement is that you do some kind of malware signature based scanning on your systems. And that's certainly a good thing to do, but it's not nearly as good as like an EDR, like active detection response platform. And so that's why that's what I mean by it's like it's a lagging indicator of like too many companies don't have any malware detection. And absolutely, if you don't have any, you should do it. But really the North Star is like implementing any of the EDR, cloud EDR providers. First of all, on your like Windows servers if you have them, but then going into like the container space, the Kubernetes space, like Kubernetes EDR is not going to be a compliance requirement for like 5 to 10 years, like on the shallow end, is me guessing at that. But it's the best security you could have, and it's not going to show up on any of these frameworks because it's like expensive, hard to implement. The technical skill sets aren't there for a lot of organizations, and so that's sort of where I'm coming from as far as like it's a good North Star if you don't have anything, but it's not like the actual thing that you want. And there's other ways to check that box, I guess is what I'm saying. Because the danger you could run into is thinking like, oh, SOC 2 says we need a malware scanner. We need to buy a malware scanner. But really, you should buy an EDR provider that you can also say is a malware scanner because they also do that. And so that's just sort of, we're being careful in terms of how are we meeting these things. All right. There's nothing else. I'm gonna hop on over to excuse me.
Let's go for it.
Incident response. And so this is the final slide we have, and it's also it's simultaneously like the most important and most challenging to do. And that's there are so many tools out there right now in a cloud context that focus on configuration scanning and vulnerability management. And in the industry, that is definitely where the emphasis has gone, especially with like shift left ideology and the importance of fixing misconfigurations early. But it's important that you actually know, and this is part of the real security stuff, how am I going to actually respond to an incident that gets detected? And where do I actually have coverage of my runtime protection? So in my mind, I drive a hard distinction between configuration scanning and runtime alerting. And the main reason I do that is part of what we talked about in the foundations part is because I fundamentally view those alerts as going to two different people. A configuration scanning alert is going to go to a developer or DevOps person to fix the misconfiguration, whereas a runtime alert is something that I, as a security person, can actually do something about, right? So if I get an alert that a shell got launched from a web process, I can actually kill that process. I can kill that pod. I can isolate the container. I can look at logs to see how they were able to build a reverse shell from their web process. There's things I can do with log data and quarantining and response. And so that's why I like this is the part that's actually meant for me as a security user, as opposed to like, oh, I got this ticket that I should go tell a developer to fix this thing, where they could have just gotten the ticket / alert themselves to do the thing. And I'm really not providing much value as a security person in that context. And so that's why I think it's important to emphasize the incident response aspect of, first of all, how do you have what does your actual coverage look like? And this can be really hard to do granularly and to roadmap, because a lot of times people will buy like one endpoint provider and think that it's covering like all their bases. And so they'll really overlook, like, do we actually have enough container context to discover what's happened? And a good example of this, most prominently, is like AWS guard duties, like Kubernetes alerts, where they will tell you, like, we've noticed an increase in web traffic from this EC2 node, but they won't provide any data of like, here is the pod and the namespace and what it did, which is like step one of what you would need to have any hope of troubleshooting that alert. And so it's like, do we actually have enough data to troubleshoot and get visibility into an attack if it were to actually happen? And so one of the things we have on that Latio website is an insecure Kubernetes deployment. And one of the things that I love about using that is you can actually validate, like, if someone were to create a reverse shell in our infrastructure, would we even detect it? Would we detect someone uploading a file to our container images? These are the things that really are the next level of an application security program. And that's when we talk about the application context. What is an incident? Runtime application security, or RASP, as the technology sometimes called, is like, in my mind, the gold star of security, because it's really advanced stuff where you're working with developers on their log data, to both identify the threats that are happening by looking historically at the logs, or by proactively building in security to the application itself. And so a couple ideas of that are doing something like killing a user session if you notice that it's starting to run SQL injection attempts, or checking user passwords against known databases of breached passwords. These sorts of additional or like actions that a user might be taking, trying to authenticate without MFA happening. These sorts of alerts where you're working with developers and thinking about malicious things that a user could be doing. Excuse me. And it's just important to make those things actually actionable, in terms of, because a lot of times you can get these alerts and you're like sending them to some SOC analyst who can like do nothing about it. And so it's important that you're building, as much as you can, like programmatic responses to this stuff. Like, can we kill the user session? Should we force a password reset? Can we block an IP on the fly if it goes into a honeypot or something? Like, these are pretty advanced application level responses that you can build into your roadmap as really cool projects to work with developers on. And on the flip side of that, I think it's important that a misconfiguration is not an incident, in terms of a lot of SOCs, security operations centers, get absolutely drowned by these new cloud tools and how they can treat a runtime alert the same way as a misconfiguration, where like all of a sudden some security analyst who's supposed to be getting like, when an attacker is running an Nmap scan from a laptop or something, gets an alert that like an RDS database is unencrypted. And that's something that like they can't do anything about. Like, it's totally pointless to have them get the alerts for that. And so thinking about what you're treating as an incident, what type of alerts, and then getting those alerts to the right people on the right timelines. And then finally, this is where we talk about the SIM stuff, is your SIM does still have a use case within all. There's a lot of tooling now in the application and cloud security worlds that sort of reduce the need for a SIM, because they're essentially looking at CloudTrail and workload logs, workloads using eBPF, CloudTrail on the cloud side, application essentially looking at the same, not logs strictly speaking, but looking at the configuration data inside the CI/CD pipeline. And so this is when you're ready for the more advanced stuff. Like that's where you start using the sim to build custom rules and custom correlations. And this in my mind is something that you should always have someone working on, is maintaining a list of here are our detections in our environment and how are we continuing to mature those over time. Otherwise, it's something that gets very left out of the equation because it is hard and somewhat monotonous work, which is not something that people enjoy doing. But it's extremely important to have a clear, constantly working, like having meetings with developers and saying, hey, if someone were to exploit this service, what would it look like? How would we detect that? How would we want to respond to that? These are conversations that you have to intentionally go out of your way to have, and they're not going to happen like organically. A dev's not just going to be thinking about like, oh, that service I built 8 months ago, like maybe someone could do this to exploit it. So really with incident response, it's all about just driving that consistent growth into across all of your teams and working with them to build a meaningful response process. I'll pause there.
Thank you, James. That's very insightful. You mentioned about RISP, and I have a question regarding that. In the past years, you have heard a lot speaking about like shift left security and application security and product security. I've heard in the application security community, people claiming that no, the technologies are so good that only SCA plus SAST plus RISP would be enough to ensure comprehensive product security. What do you think of that? Do you think like the RISP technologies are mature enough to ensure proper security with such a limited amount of tools? Or do we need something more?
I think that's a very application-y way of looking at things. And so my background's more in the cloud and DevOps side, and I'm sort of newer to the application space. And so like I very much am like, no way. Because like if you get an SSH to a box, like your Raspbi's, your SAS, your SCA is like not helping. Like that's where you need an EDR and something looking at like the eBPF logs at least to determine what happened. But from an application perspective, I definitely think, and even like at the end of the day, your SAST SCA is only as good. Like it's like anything where the hardest problem is like the last mile validation. Like when you're running cable, when you're delivery, like there's entire delivery companies of like the last mile stuff where it's like a lot of DevOps teams are doing very scary things to your application, like the second before they start running on the cluster. And the only way you're going to catch that stuff is if you're doing some sort of runtime validation. And so I like the SAST plus DAST story of like the DAST validating that the SAST results are there. And honestly, every true positive that's been like a major true positive that I've caught has come both from the DAST and the SAST. I have trouble thinking of a SAST example where I've seen this like, wow, this SAST tool really blew my mind and found this like groundbreaking public, like we could be totally hosed situation. But I have seen that with DAST, and I think it's because of that last mile validation. On the runtime side specifically, I think Datadog's Raspberry is probably the best stab at it that I've seen, and they have the best hope because like developers are already importing Datadog packages sometimes to their app. But at the end of the day, like the reason Raspberry is so hard is because you have to like get developers to like import a package and then do stuff with it. And so that's why,
absolutely, and this is why they made the strategic acquisition of Screen to merge actually the result of the research from Screen into the Datadog agent, right?
Yep. And that's I think that was a brilliant acquisition from them. And I think if anyone knows of a better Raspberry tool that like does it out of the box, because like obviously you can build this stuff with like the Prometheus logs or whatever you're using for telemetry stuff, and then send the alerts to PagerDuty, of course. But you can really build all of that stuff. But I don't know who does it extremely well out of the box besides Datadog on that. So just to answer a couple of these questions that popped up, I'll start with Jacob's because it came up. If you go to that list.latio.tech, you can get all of my thoughts on DAST and SAST stuff. Obviously, I can recommend Escape for DAST stuff.
Thank you for this.
Yeah, they're an easy recommendation. But the thing with DAST is it's become very. I just do want to say this really quickly. I know we're going over time, but it's become very popular to say that like DAST is dead or something. And it's like, that's just because like 90% of DAST tools are legacy and suck. So like, I won't name them all here just to keep myself out of trouble, but like there are plenty of awful DAST tools that like crawl your app, miss a bunch of stuff, take hours to run. There's only a couple examples of tools that can run in pipeline and ingest your API data, read the API documentation and fuzz those endpoints directly. And that's the value of a DAST tool to look for. SAST, there's a million recommendations on that site that I won't go into, but they have the same problem, right? Like the biggest legacy players in SAST and DAST both like can't run in pipeline. They take hours to run. The UI sucks. You're drowning in alerts. Like they just totally don't understand how modern applications get built and deployed. And so that's where I would really like, I think that this market in particular is really valuable to look at startups or smaller companies as opposed to the giant legacy players.
Yeah, I totally agree with that, and especially when it comes to DAST, what we discovered is the legacy DAST tools were mostly based on open source tools or on testing engines that were created in the early 2000s, designed for testing old school PHP or Ruby on Rails applications. And they have not really been designed to test single page apps or to test APIs or to be integrated into CI/CD pipelines. So this is one of the reasons when we started Escape, we wanted to create something different with DAST, and we built actually our own engine from scratch with the goal of integrating it in the DevSecOps lifecycle and testing single page apps and APIs. For the SaaS tools, I believe there is also a lot of innovation in the field, and I've seen like new tools. There is a GitHub that created CodeQL, which is quite interesting. There is SameGrep also doing some interesting projects when it comes to easy to use SaaS and easy to personalize SaaS tools. So there are a few tools, and I'm sure James, you have created a great listing of those in Latio.tech.
Yeah, and the thing to keep in mind just when you're looking at this stuff is like ASPM has become the new buzzword for it. And so a lot of ASPM providers include SaaS scanning as a part of their offering. So that's just something else to like make sure you don't, because if you just Google like SaaS providers, like the ASPM people won't come up even though they also provide it. And then just to hop on the Varun's question real quick as well, this is like the $1 million question as far as like, what do you do with false positives and SCA scanning? This is a problem that like everyone is trying to solve. I think Endor Labs does the most innovative. I mean, they were the first to do like function level reachability to rule out false positives. And so that's one way to sort of cut down on stuff. But the problem is a lot of CVEs don't include the function data as far as like this is exploitable or not. So some stuff that I've had success with is really trying to narrow the scope as much as possible in terms of what are we trying to fix here and focusing like quarter by quarter on specific applications instead of trying to boil the whole ocean with like, here's all these vulns. The second sad realization I've had is that like automated fixes for this stuff is like sort of a dream. So I wouldn't try to do it. It can work on the container vulnerability side because all you're doing is rebuilding the container. But on the SCA side, like at the end of the day, someone needs to bump that version of the dependency and it could break your entire application. Yeah, I have a LinkedIn post on reachability analysis. I'm working on a blog with Endor on it that I think will be helpful for like what that means and the different things you can do to prioritize that stuff. But at the end of the day, like it is a giant problem that at the root level requires clear application ownership and timelines. And I do think in this case, you need like the top-down commitment to that where these teams own these repos and they will patch things within these 90 days, or else it's not going to happen magically.
Yeah, exactly. Thank you, James, for answering those questions. I think SCA is really like nice because it's fairly easy to integrate into a development process. It's very easy to connect, but then when it comes to fixability and reachability of the vulnerabilities, it becomes quickly a problem.
Oh, let me. Sorry, there is a tool called Modern that I haven't dug into too much personally.
Interesting.
But what's really cool about them is they focus on like automating the remediation actions, and so things like if you've ever updated like a Spring Boot across your Java fleet, like what a nightmare that is. But they say that they can automate a lot of it, and so I haven't tested it personally, but I know that they're the ones who are the closest to what I would actually trust as far as like an automated action for it.
Excellent. I'm glad to see more innovation in that field. I think in the past years there has been like a regain of interest into innovating in cybersecurity, and I'm glad to see more projects like that. And here we have OWASP.
Yep. The I am sure that's what everyone who does it is secretly using, and then they've built their own little magic sauce on top of it that you can pay for. Yeah.
Sneak is looking at us right now.
Yes, it's just everyone. I mean, the whole yes. That's why I appreciate there's some providers like Aikido that I just love how they will say like, hey, here's the open source scanners we're using. And they're not trying to hide it behind all these layers of, oh, we've built our own thing. So
yeah,
yeah,
of course. Okay, so we are a bit over time. This was super interesting, James, to hear you speak about your experience on the security roadmap and hear your advice on crafting the right security roadmap. I especially discovered the runtime part and the incident response part because we at Escape are specialized more into the DevSecOps and the code security part and dynamic analysis. Thank you so much for sharing this with us. I hope all the viewers appreciated this session, and thank you all for coming. This will be available on YouTube as a recording, and we hope to have more sessions like this in the future.
Yep. Thank you, everybody.
Thank you, everyone, and have a great day. And if you want to check on all the tools that we have mentioned, you can check out lasio.tech. And if you want to check out modern application security, API security, and DAS tool, check out escape.tech for more content like this. Thank you and have a great day.